Here we are with a beautiful problem from complex number. Actually, when the first time we are reading this problem, we won't understand then this is a problem from complex number, because it seems as if this is a problem that we can solve using coordinate geometry, or some will think some other way using sequence and series, because such kind of problems we have seen in sequence and series. But one thing that we need to keep in mind is that a very similar problem is asked in sequence and series, but that angle in that kind of problems are given as 90-degree, and it becomes a kind of infinite geometric progression, and we solve it accordingly. But this, here we can see the angle is 60-degree. So first let us read the question. Insect starts from point P, it moves 1 unit due north to point P1 for I greater than equals to 1. Once the insect reaches point Pi, it turns 60-degree counterclockwise and then moves I plus 1 unit straight to reach point Pi plus 1. When it reaches P 2023, it is exactly x unit away from P. So let us draw the diagram for this question. Let me consider the direction sense as north, east, south, west, right? I can consider my directions. I have this liberty. This is P, this is P1. And for I greater than equals to 1, I greater than equals to 1, let us satisfy the condition. I'll travel I plus 1, I plus 1 in counterclockwise direction. Let me write it as pi by 3. I'll move on to this point P2, right? And this distance that I have traveled is 2 units, right? From P2 again I will travel making an angle of 60-degree with P2. I'll travel 3 units to reach P3, and this angle is again going to be pi by 3. Okay, this angle is again going to be pi by 3. These angles, okay. So what we can do, we can generalize it a little bit more. That I have started from pk minus 1 to reach the point pk, traveling distance k, and again I have traveled k plus 1 distance to reach point pk plus 1. Now I can replace this point with complex number. Why I am replacing this point with complex number? Because in complex number, see, why I am not solving the problem with coordinate geometry and considering the point pk plus or pk as some x comma y or xk comma yk, because here we will get two variables, but when we are solving a problem using complex number we get only one variable, right? That's e to the power iota theta, some z naught, or you can say r naught into e to the power iota theta. And that makes approaches using complex number a little bit more easier, because we are solving the equation in only one variable. That's why complex number is more useful in such cases than compared to any other counterpart methods, say vector or coordinate geometry. So let us replace this as points in the Argand plane zk plus 1, zk, zk minus 1, right? So I have three such points. I have three such points. Now what I will do, this is method 1. This is method 1. Just wait a minute. This is my method 1, that I'll use the concept of rotation of complex number in zk plus 1, zk and zk minus 1, and what I will get, zk plus 1 minus zk, zk minus zk minus 1 will give us k plus 1 over k e to the power iota. We are rotating it by 60° iota pi by 3 angle, right? But here we can easily establish a recurrence relation and find out the required zk. But one thing we can see is that here we have 3 variables, right? So this will give us a second order recurrence relation, and it is very difficult for us to compute a second order recurrence relation. At least from JEE point of view, this sum will be irrelevant for us. So obviously, since we are practicing this question in the JEE, there is some alternative method which doesn't involve this kind of 3 values, and we can easily compute it. So what is our another possible method? Let me just bring this diagram here. Yes, fantastic. Let us have a look. Let us have a look. This is our method 2. This is going to be our method 2, right? How much angle here we have rotated? Pi by 3. And how much angle here we have rotated? Again pi by 3. And finally, we are in the point P3, right? So with respect to this, as we all have studied, most probably you have studied in physics, when a ray of light is rotated first by delta 1, again by delta 2, the net deviation we are finding using delta 1 plus delta 2. The same thing we are going to do it here. The net deviation, you can say, or the net angle rotated, total angle rotated with respect to this line, for a more generalized point, let's say for P3 P2, for P3 P2, how much we have rotated? P3 P2, 2 pi by 3, right? So for pk plus 1, pk, how much we have rotated? K or I, whatever variable it use, it doesn't matter. We have rotated k times of pi by 3, right? So now we will use this in rotation of complex number. That will give us a very easy result. Let us again draw the diagram. Let us copy this diagram. Let us draw a fresh diagram. Let me consider P as the origin. P as the origin, and this is a P1, which is 1 comma 0, or you can say 1, because it's in the real axis. Okay, this is our real axis. This is our real axis, and this is our imaginary axis. This is 1 comma 0. This is 1 comma 0, and this is some general line, pk plus 1, whose length we know is k plus 1, and which makes an angle of k pi by 3 with the x-axis, or you can say the real axis, right? So now we will apply rotation of complex number here, pk plus 1 minus pk and this is real number. P1 we know is 1, and P is what, 0. P is what, 0, and their magnitude is also 1, and this is K. Their magnitude is K. E to the power iota K pi by 6. So now this relation is a very beautiful relation, K plus 1 minus Pk, K times of e to the power, sorry, this is K plus 1, this is K plus 1 this is K plus 1, this is K plus 1 e to the power iota K pi by 6, right? So here we can see that this is a clearly this is a telescope relation, you can say, and from here we can easily compute. Let us give you some more insights. We need P2023, right? We need P2023. So let us write few more terms. Before that, let us replace e to the power pi by 6 with P. Okay, not P. Which variable should we use here? Say we replace it by beta. So it replaces by beta. Fantastic. So let me write P2023 minus P2022 is 2023. This will be iota. This will be iota. Beta to the power 2022, right? So on we will write. Let me write one more term, 2022 minus of P 2021 equals to 2022 beta to the power 2021. So on, if we continue, we'll get P2 minus P1. P1's value is known to us, that's 1, nothing else but 1. 2 into beta, right? 2 into beta. Adding this, what we will get? All these terms will get cancelled out. 2023 minus 1 is 2 times of beta plus 3 times of beta square, so on. 2022 beta 2021 plus 2023 beta 2022 and P 2023, P or Z, whatever. Actually, in this step, we use Z, and here we replace the complex number as P only. We consider P as complex number, Pi or Pk as the complex number. So don't confuse with that. 1 plus 2 beta plus 3 beta square, so on. You'll get the sum as 2023 beta to the power 2022, right? So we have the value of P2023, and we can easily find out the distance between the origin and P2023. That's modulus of the complex number, nothing else. That's modulus of the complex number and nothing else. So how we will compute this sum? This sum, as you can see, is AGP, kind of AGP. So there are two methods to compute AGP. I'll give you the two methods. I'll give you the approach. I'll not find out the sum. Neither I'm going to find out the answer. That's a home task you can do, because calculations are very important nowadays, as we have seen the 2022 paper. in JEE Advanced was very much on the calculation side, very much hard on the calculation side. So let's focus on calculation also. So what are the two methods for those who have studied sequence and series? Sequence and series. They know this method. Obviously, they know this method. Let me write it more general. S is the sum 1 plus 2 beta 3 beta square, so on, k plus 1 beta to the power k. What they will do, they will multiply it with ks, k plus, sorry, not k, multiply it with beta, beta plus 2 times of beta square plus 3 beta cube plus so on, k into beta to the power k plus k plus 1 into beta to the power k plus 1, and they will subtract it. Let me subtract in s minus beta s. They will subtract it. 1 plus beta plus beta square, so on, beta to the power k plus, sorry, minus, this will be minus because no one can cancel this term, minus k plus 1 beta to the power k plus 1. Now this is a geometric progression, and using this we will find out the value of s, right? This is the sequence and series method. Now I'll give you another method. This method we will study in binomial theorem. Most possibly all the students learn this method in binomial theorem. Those who don't know the method, for them this method is important. See, again, let us write this sum as some function of beta. One plus 2 beta 3 beta square, so on, k plus 1 beta to the power k. Can we observe one thing? Can we observe one thing? That if we integrate this with respect to beta, if we integrate this with respect to beta, what we will get? Or forgot integrating. This is a very easy pattern for us to observe. If this is beta square, and if we differentiate beta square with respect to beta, what we will get? 2 beta. If this is beta cube, and we'll differentiate this with respect to beta, what we'll get? 3 beta square. Similarly, this is what? Differentiation of beta to the power k plus 1, right? So can we write this? Can we write this in this way? One is what? One is simply differentiation of beta with respect to beta. Can we write this? This is f dash beta, where f of beta is sum beta plus beta square, so on, beta to the power k plus 1. Now what we will do here, this is a GP. We will write this product of GP here. We will write this product of GP. And then we'll differentiate both sides of the equation. After differentiating, here we'll write this as a GP. product of G as sum of GP, sum of GP, and then we will differentiate both side. After differentiating, you will get the value of this expression in the form of a sum. Getting my point? And this is the method to solve this kind of problem. Definitely this kind of problems and this kind of approach will blow your mind if this comes in JEE advanced or any other examination, because this you cannot think in an instant. For this you need some insights and you should know such kind of problems. So this is one of its kind of problem. This is very good problem, both of coming in any kind of intermediate level examination.